Hello everyone, welcome to new class. Today's class is about economics of power generation. That is the continuation of power systems. So today's topic is economics of power generation. So the problem of determining the cost of production of electrical energy is highly complex and poses a challenge to power engineers. And there are several factors which influence the production cost, such as cost of land and equipment, then depreciation of equipment, interest on capital investment, etc. So therefore, a careful study has to be made to calculate the cost of production. So economics of power generation means the art of determining the per unit cost of production of electrical energy. So there are several factors which influences the production cost, and there are some terms that are used in the economics of power generation. First one is interest. So what is interest? The cost of use of money is known as interest. Cost of use of money is known as interest. So a power station is constructed by investing a huge capital, and this money is generally borrowed from banks or other financial institutions, and the supply company has to pay the annual interest on this amount. So while calculating the cost of production of electrical energy, the interest payable on the capital investment must be included. The next one is depreciation. So what is depreciation? The decrease in the value of the power plant equipment and building due to constant use is known as depreciation. That is, from the time the power station is installed, the equipment steadily deteriorates due to wear and tear, so that there is a gradual reduction in the value of the plant, and this reduction in the value of plant every year is known as annual depreciation. And due to the depreciation, the plant has to be replaced by the new one after its useful life. Therefore, suitable amount must be set aside every year, so that by the time the plant retires, the collected amount by way of depreciation equals the cost of replacement. So, while determining the cost of production, the annual depreciation charges must be included. So, these are the two terms that we have to consider while determining the cost of electrical energy. Next is cost of electrical energy. The total cost of electrical energy generated can be divided into three parts: fixed cost, semi-fixed cost, and running or operating cost. First one is fixed cost. It is the cost which is independent of maximum demand and units generated. And the fixed cost is due to the annual cost of central organization, then interest on capital cost of land and salaries of high officials. Then next one is semi-fixed cost. It is the cost which depends upon the maximum demand, but it is independent of the units generated. And the semi-fixed cost is directly proportional to the maximum demand on the power station and is on account of the annual interest and depreciation on capital investment of building and equipment, then taxes and salaries of management and clerical staff. Then next one is running cost. It is the cost which depends upon the number of units generated only. And the running cost is on account of annual cost of fuel, then lubricating oil, maintenance, repairs, and salaries of operating staff. Next is expressions for cost of electrical energy. The overall annual cost of electrical energy generated by a power station can be expressed in two forms, that is three-part form and two-part form. So in three-part form, the overall annual cost of electrical energy generated is divided into three parts, that is fixed cost plus semi-fixed cost plus running cost. And here fixed cost is constant, then semi-fixed cost is proportional to the maximum demand, then running cost is proportional to the kWh generated. That is, we can write rupees A plus B kW plus C kWh, where A is the annual fixed cost independent of the maximum demand and energy output. B is the constant which when multiplied by maximum kilowatt demand on the station gives the annual semi-fixed cost, and C is the constant which when multiplied by kWh output per annum gives the annual running cost. Then in two-part form, the annual cost of energy is divided into two parts, that is fixed sum per kW of maximum demand plus a running charge per unit of energy. That is, total annual cost of energy can be expressed as rupees A into kilowatt plus B into kilowatt hour, where A is the constant which when multiplied by the maximum kilowatt demand on the station gives the annual cost of the first part. Then B is a constant which when multiplied by the annual kilowatt hour generated gives the annual running cost. And here the two-part form is the simplification of the three-part form. Next is importance of high load factor. So the load factor plays a vital role in determining the cost of energy. So the important advantages are it reduces the cost per unit generated. So a high load factor reduces the overall cost per unit generated. That is, higher the load factor, lower is the generation cost, because higher load factor means that for a given maximum demand, the number of units generated is more, and this reduces the cost of generation. Then second advantage is it reduces the variable load problems. So a high load factor reduces the variable load problems on the power station. So let us do one problem. A generating plant has a maximum capacity of 100 kilowatt and cost rupees 1,60,000. The annual fixed charges are 12% consisting of 5% interest, 5% depreciation and 2% taxes. Find the fixed charges per kilowatt hour if the load factor is 100% and 50%. So here it is given that maximum demand is 100 kilowatt and annual fixed charges. So we have to find annual fixed charges. Annual fixed charges is equal to, it is given that annual fixed charges are 12 percentage. So it is equal to 12 percentage of the cost, that is 1,60,000. That is 0.12 into 1,60,000, and that is equal to 19,200 rupees. Now we can find the fixed charges per kilowatt hour. That is for the load factor 100 percentage. The units first of all we have to find the units generated. So units generated per annum is equal to, we have the equation maximum demand into load factor into hours. So units generated per annum is equal to maximum demand into load factor into hours in a year. So maximum demand is 100, then load factor is 100%, that is 1 into hours. Hours in a year is 8,760. So we get 8,76,000 kilowatt hour. Then what will be the fixed charges per kilowatt hour? So fixed charges per kilowatt hour is equal to, fixed charges is 19,200 divided by kilowatt hour, that is the units generated is 876,000, and we get 0.0219 rupees, which is equal to 2.19 paise. Now when the load factor is 50 percentage, that is load factor is 50 percentage, then what is units generated per annum? So units generated per annum is equal to, maximum demand is 100 into 0.5, load factor is 50 percentage, then into hours 8760, and that is equal to 4,38,000 kilowatt hour. Now we can find the fixed charges per kilowatt hour. That is fixed charges per kilowatt hour is equal to 19,200 divided by this one, and that is equal to 0.0438 rupees, which is equal to 4.38 paise. So when the load factor is 100 percentage, the fixed charges per kilowatt hour is 2.19 paise, and when the load factor is 50 percentage, it is equal to 4.38 paise. So by decreasing the load factor from 100 percentage to 50 percentage, the fixed charges per kilowatt hour have increased twofold. So this illustrates the utility of high load factor. So higher the load factor means it reduces the cost per unit generated. So that is about the basics of economics of power generation. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.